Have you ever imagined controlling a 3D airplane just by moving your hand? Well, that's exactly what I have built. Using an MPU6050 motion sensor and a XIAO ESP32-C3. Every tilt and rotation of my hand is transmitted in real time to this 3D airplane on my computer. In this video, I will show you how I built the complete system, from hardware connection to programming and the 3D visualization. So let's get started. We will require the following components for this project: ESP32C3, MPU6050 sensor, breadboard, and some jumper wires. Before we start building the project, let's take a quick look at the XIAO ESP32C3. This tiny development board from the Seeed Studio is powered by ESP32-F ESP32C3 microcontroller, featuring a 32-bit RISC-V processor running at up to 160 MHz. Despite its compact size, it comes with built-in Wi-Fi and Bluetooth Low Energy, making it perfect for IoT and wireless applications. It also offers multiple GPIO pins, I2C, SPI, UART, PWM, and ADC support, allowing it to interface with a wide variety of sensors and modules. In this project, the XIAO ESP32C3 read real-time motion data from the MPU6050 sensor through the I2C interface and sends the orientation data over USB serial to control a 3D airplane model on the computer. Its small size, low power consumption, and impressive performance make it an excellent choice for embedded and motion controlling projects like this one. Now let's talk about the MPU6050, which is the heart of this project. The MPU6050 is a compact and highly popular motion tracking sensor that combine a 3-axis accelerometer and a 3-axis gyroscope into a single chip. Together, these sensors provide 6 degrees of freedom, allowing the device to detect the movement, tilt, rotation, and orientation with excellent accuracy. The accelerometer measures acceleration along the X, Y, and Z axes, which helps determine the sensor tilt and movement relative to gravity. On the other hand, the gyroscope measures angular velocity, meaning it detects how fast the sensor is rotating around each axis. By combining data from both sensors using sensor fusion algorithms, we can obtain smooth and stable roll, pitch, and yaw values in the real time. One of the biggest advantages of the MPU6050 is its simple I2C communication interface, which require only two data lines, SDA and SCL, to communicate with a microcontroller. It operates at 3.3 volts, but it also compatible with many 5-volt development boards through its onboard circuitry, making it very easy to integrate into different projects. In this project, the MPU6050 is connected to the XIAO ESP32C3, where it continuously measures the orientation of my hand. The ESP32C3 processes this sensor data and sends the roll, pitch, and yaw value to the computer through USB serial communication. The visualization software that uses these values to rotate the 3D airplane model in real time, creating a smooth and highly responsive motion control experience. Because of its low cost, high accuracy, and ease of use, the MPU6050 has become one of the most widely used sensors in robotics, drones, self-balancing robots, gaming controllers, virtual reality systems, and many other motion-based applications. Now let's understand the circuit diagram of this project. The hardware setup is very simple and consists of only two main components: the XIAO ESP32C3 and the MPU6050 motion sensor. The MPU6050 communicate with the microcontroller using the I2C protocol, which require only 4 connections. The VCC pin of the MPU6050 is connected to 3.3 volt, while the ground pin is connected to the common ground. For data communication, The SDA pin of the MPU6050 is connected to GPIO pin 6 of the XIAO ESP32-C3 and the SCL pin is connected to GPIO pin 7. Once these 4 connections are completed, the sensor continuously measures the roll, pitch and yaw of the board. Let's briefly understand how this Arduino code works. First, the required libraries are included. And the I2C communication pin of the XIAO ESP32-C3 are configured. During startup, the MPU6050 sensor is initialized and the gyroscope is calibrated by collecting multiple samples, while the sensor remains stationary to remove bias and improve accuracy. In the main loop, the code runs at approximately 100 Hz. It continuously reads the accelerometer and gyroscope data from the MPU6050. A complementary filter combines both sensor reading to calculate stable, roll, and pitch angles, while the gyroscope Z-axis is integrated to determine the yaw angle. An exponential smoothing filter is then applied to reduce noise and produce smoother motion. Finally, the processed roll, pitch, and yaw values are transmitted through the USB serial port. These values are received by the Python application, which rotates the 3D airplane model in real time according to the sensor movement. To run the Python program, we first need to install the required Python libraries. Open the command prompt inside the project folder, where the requirements.txt file is located. Then type the command pip install -r requirements.txt and press enter. It will take a few seconds to download and install all the required libraries automatically. Once the installation is complete, your system will be ready to run the Python application. Before running the program, make sure all the required project files are located in the same folder as main.pv. This includes the airplane.object 3D model, the airplane.mtl material file, the texture.png image, and all the supporting Python files such as serial reader, renderer, camera, HUD, model loader. Keeping all these files in the same directory ensures that the program can successfully load the 3D model, textures and required modules without any startup errors. Now let's run the main Python program. As soon as the application starts, you can see the 3D airplane model appear on the screen. By simply dragging the mouse, we can rotate the camera and view the airplane from different angles. Using the mouse scroll wheel, we can zoom in and zoom out to get a closer or wider view of the model. At the moment, the MPU6050 sensor is completely stationary, so the airplane also remains perfectly still. Now let's start move the sensor. As I tilt it, you can see the airplane immediately begins rotating in real time. Every small movement of the sensor is detected accurately, and the airplane follows those movements smoothly. When I place the sensor back on a flat surface, the airplane also becomes stationary. I can still use the mouse to change the viewing angle, while the sensor continues controlling the airplane orientation. As I move the sensor in different direction, the airplane changes its attitude accordingly. Finally, when I flip the MPU6050 sensor upside down, the 3D model also flipped instantly, demonstrating that the system accurately tracks roll, pitch, and yaw movements in real time. This shows that how XIAO ESP32C3 and MPU6050 work together to provide smooth and responsive motion control for the 3D airplane visualization. And that's it for today's project. We successfully built a real-time 3D airplane motion visualization system using the XIAO ESP32C3 and the MPU6050 motion sensor. By combining embedded programming with Python and 3D graphics, we create a smooth and responsive visualization that accurately tracks the sensor orientation in real time. I hope you found this project informative and learned something new. If you enjoyed this video, don't forget to give it a thumbs up. Subscribe to the channel and turn on the notification bell so you never miss any upcoming Arduino, ESP32, IoT and AI project. If you have any questions or suggestions, feel free to leave them in comments below. Thanks for watching and I will see you in the next video.